for your love, darling, everything.
My name is Trevor Burkhart. I'm a senior at the University of Akron, and my major is construction engineering technology.
I'm giving it up for your love, darling.
My name is Logan Vincegara, and I'm a junior in construction engineering technology.
I'm giving it up for your love, darling, everything.
Hey guys, I'm Tristan Votava. I'm a senior in the CET program, and I'm really excited to teach you about some positive displacement pumps today.
So today we will be talking about positive displacement pumps. We will describe how they work. We will list different types. We're going to compare the energy at the inlet and outlet using Bernoulli's equation. We will show how the energy of a pump is added to a system using Bernoulli's equation. And then we will talk about real-life applications for these positive displacement pumps. So now we're going to start talking about how these positive displacement pumps work and different types of positive displacement pumps. Fluid is drawn into a fixed volume chamber at the inlet and then moved to the outlet by means of either reciprocating or rotary motion that causes pressure. These cycles rely on the pressure that is created mechanically. Positive displacement pumps have consistent flow and work effectively with high viscosity fluids. This is an advantage over centrifugal pumps, which flow varies according to changing pressure and can only handle low viscosity fluids. This is a reciprocating pump. And what we see here is that the piston is moved backwards, causing the fluid to be drawn into the chamber, filling it up. Then the piston moves forward, causing a pressure that pushes the water out towards the top of the pipe. This mechanical pressure is what causes that consistent flow that is desired by these pumps. These are rotary pumps. Rotary positive displacement pumps use pressure that is caused by gears in order to transfer the fluids. The rotation of the gears causes a suction effect that draws the water through the pipes, causing a consistent flow. The top pump is an internal gear pump. This consists of two gears that interlock, but one is rotating inside of the other. The bottom pump is an external gear pump. These also have two gears that interlock, but they are on separate shafts. The water is pushed along the outside of the gears because the center is interlocked.
Hey guys, I'm Tristan. I just wanted to talk a little bit today about positive displacement pumps and how they add energy to a system. And also I want to talk about how energy differs at the inlet and how energy is at the outlet of this pump. To aid me in my explanation of positive displacement pumps, we're going to take a look at a piston pump. This image here is a reciprocating positive displacement pump, and it is comprised of different components such as the encasement, the cylinder, the piston, which is driven by the connecting rod, and then it also contains two valves, a suction valve and a discharge valve. When the piston is moved backwards, both valves move towards it. The suction valve opens and the discharge valve closes. Why does this happen? Well, the piston moving backwards increases the volume in the cylinder, thus creating a low pressure pocket inside, which pressure moves from high to low. So the pressure from the inlet, or the fluid in the inlet, is forced to the lower pressure system inside of the cylinder. So energy is introduced into a positive displacement pump through the changing of volumes. So in this picture here, you see that the piston and connecting cylinder have moved backwards. This creates a void where it needs to be filled because low pressure system, pressure moves from high to low pressure. So that pulls both of the valves towards the cylinder, which closes the discharge valve and opens the suction valve. This allows fluid to come in and fill the void where the volume increased. The Bernoulli principle states that with an increase in pressure, there's a decrease in velocity, and with a decrease in pressure, there's an increase in velocity. What we're seeing here, whenever the cylinder pulls backwards, we're getting a lower pressure, and that increases the velocity of the fluid. And that's how it relates to the Bernoulli principle. Next, we're going to talk about how the energy is different at the outlet of the pump. So in this picture, you see that the piston in the connecting rod have now moved forward. This collapses that volume and makes it smaller, thus it pushes both of the valves away from the piston and cylinder. This closes the suction valve and opens the discharge valve. In other words, the piston and cylinder, they're displacing the fluid that was in the cylinder and forcing it out of the chamber and up the discharge valve. In terms of the Bernoulli equation, whenever the cylinder moves to the right and forces that liquid into the discharge, it has a higher pressure in the cylinder than it does in the discharge outlet pipe. So that lower pressure in the outlet pipe increases the velocity.
A positive displacement pump makes fluid move by trapping a fixed amount and forcing that trapped volume into the discharge pipe. Some positive displacement pumps use an expanding cavity on the suction side and a decreasing cavity on the discharge side. Positive displacement pumps are most commonly used when there is a liquid with high viscosity or very thin liquid such as ammonia. Positive displacement pumps are not necessarily something the average person sees every day since they are mainly used in big factories and chemical plants. But an example that most people have seen or heard of is a hand pump for a well. By nature, positive displacement pumps create a vacuum on the suction side, so they create a suction lift. Therefore, they are used in hand wells and being able to draw the water up from the ground. The following video will explain exactly how a hand pump well works. A lift pump is a type of reciprocating pump which draws fluid in at one end and expels it at the other end. The pump consists of a piston moving to and from inside a cylinder. Two valves regulate the flow of the water into and out of the cylinder. As the handle is pushed down, the piston is raised, reducing air pressure in the cylinder. The outside air now has a greater pressure than the air inside and pushes the water up the pipe. As the handle is pulled up, the outlet valve opens, the inlet valve closes, preventing water from falling back down the pipe. As the handle is pushed down against the piston is raised, lifting the water to the spout. The outlet valve opens as the water is forced up above the piston. Water resting on top of the piston pours out of the spout. At the same time, more water is drawn up through the inlet valve. Water is pushed up into the pump by pressure of the atmosphere on the water in the well. This limits the distance that the water can be raised using a lift pump to about 8 meters.
Giving it up for your love, darling, everything. Giving it up for your love.